Hi, good afternoon, everyone, and welcome to this demo day of batch 424 of the Wagon London. I hope you can hear and see me fine, either from our campus in Hoxton or from the comfort of your home. I'm Alex. I'm the general manager of the Wagon in the UK, and tonight I'm joined by Ben Baranger, who is our data science lead in the UK. And of course, we'll be joined by our 14 students graduating today from our very first data science bootcamp. So as I just said, it will be a very, very special demo day, one that we'll definitely remember. It's the first time that we were running this data science program in London. And I know all the hard work that went into building this program over the past 18 months. Then, of course, running the first boot camps in Paris, Berlin, and London. So just before we start with demos, I'd like to thank, of course, all the team, everyone that contributed from the tech team, from the support team as well as all our students who joined us 9 weeks ago, trusted the process, and built the projects that we will discover together this afternoon. So just before we get started, a few words of introduction for those of you who don't know the Wagon yet. We're the #1 coding school in the world, thanks to our alumni, to our teaching community. It's now more than 8,400 people that we trained over the past 7 years. So it's a massive community. It's a lot of different backgrounds, a lot of different expertise put together. So you can imagine how powerful that can be. And this afternoon, we have for the 14 additional graduates joining the community. So that's very exciting. We're now present in 39 cities worldwide. London is one of them, but we're present on almost all continents. And you'll see that, of course, we're very, very practice-oriented. We focus on learning by doing, hence why we'll be discovering real-life projects tonight built by our students. We have two different flagship courses. The first one is the Data Science Bootcamp, the one that our students are completing today. The second one is the Web Development Bootcamp. We also have a demo day for the Web Development Bootcamp at 6 p.m. today, so feel free to join if you're also interested. A quick look at what our 14 students have been doing over the past 9 weeks. They've been working a lot, over 450 hours of hands-on learning with our teaching team. And the idea behind this program and the training is really to learn and build all the skills that they need to join the data team. So everything from Python and math fundamentals applied to data science, data analysis, decision science, machine learning, deep learning, data engineering, up to the final 2 weeks where they build their final projects in teams of 3 to 4 students. And I'm sure you'll be very impressed discovering what they managed to put together in only 10 days. You might be wondering, why joining the data science bootcamp of the Wagon or any other tech training provider. The idea behind these intensive tech training is really to reinvent your career, either to upskill or to reskill if you want to completely change career, but most importantly, to open up new opportunities. And this is exactly what we've been doing in the past 9 weeks. So different options. We know that our students and grads have different career plans and objectives. Some will be joining data teams as data engineers, data analysts, the data scientists. Some will be working as what we call tech-related roles. So it can be project management, product management, tech consultant, etc. And who knows, some of you might be also launching your very own company. Finally, the Wagon's mindset, as I already mentioned at the very start of this presentation, we truly believe that data and the tools that we learned over the past 9 weeks are here to solve problems, real-life problems. And this is exactly what they've been doing, building their project. So I'm now going to invite Ben to take over and introduce you to the different projects that we'll be looking at this afternoon. Ben, the floor is yours.
Hi everyone, I'm Ben. I'm the data science lead here at Wagon London, and I had the pleasure to follow our 14 students during the past 9 weeks. They spent the last 2 weeks building a project in groups of 3 or 4. So let's discover those together. Each group will be able to answer a few questions. So don't hesitate to use the chat tab on your right side in the sidebar to ask a few questions. Our first group is Resensify. We all know how reviews can make or break a product or a service. They decided to explore that deeper using data science. Let me invite Lucas on stage so he can tell us more.
Hey everyone, can you hear me? Cool, I'll take that as a yes. Great, so let me share my screen with you. Entire screen, all good. Yeah, it seems to be working. Well, let's launch the app here on the right as well. Great. Hi everyone, my name is Lucas. I have been having the joy of working together with Paulette and Mohammed over the last 2 weeks. And over the last almost 9 weeks, I have had the joy of being one of the first data science students here in the UK, and it's been an absolute pleasure. Thank you so much for all of that. Our project today that we want to present to you is called Resensify. We want to make sense of sentiment. And what we mean by that is we want to predict sentiment. We will use customer reviews for that so that we can, as I just said, predict sentiment, whether the review is either positive or negative, and also if the review will be a 5-star, 4-star, 3-star, 2-star, or 1-star review. The technology that we're using for that is called NLP, and I'll talk to you about that more on the next slide. NLP stands for natural language processing, and it's basically a way for computers to understand the language that we use, and of course also the meaning that we try to make, basically. Where we can use NLP is, for example, with sentiment analysis, which is what we are talking about today, but also whenever you use what's called Google Plus, I think, or Siri, for example, that is, for example, speech recognition. Whenever we use these sort of things, NLP is basically being used. Same for chatbots. Whenever you're on live chat and you're talking to somebody and you feel like there's not really a human being that's answering, that is NLP that is answering your request. There are, however, many challenges with NLP. For example, one of them is basically just the size of vocabulary that we're using, and it's growing every day. So we have new words, we have new buzzwords coming in. There's different meanings. For example, football. Football is something else in Australia and the US, even though they don't even play it with a ball and they don't even play it with their feet. They play with their hands. But it means something else. And for computers, this is really difficult to understand what we mean. There can be puns as well, and of course we do make typos. So it's challenging for us human beings. It's even more difficult for the machines to understand that. And if you ever ask yourself why they hired this person for the Terminator, well, it's probably because he can't really speak English. And now we know why. Sorry, does it ever get old? I had to include it. Sorry for that. Great. So what is our goal? Our goal is, of course, to use NLP, as I just said earlier, to predict whether a review is positive or negative. And we want to predict how many stars any given review will yield. And we have the app, which we will show you at the end of that presentation, which we'll use for that. So what was the model that we used for all of this? We decided to go with the BERT model. It's the state-of-the-art NLP model. It's been designed by the AI team at Google Translate at Google, and also search team at Google is using it as well to understand the sentiment of any search request. What makes BERT stand out is the bidirectional approach. So other and older NLP models used to look at any given sentence and read it from left to right, or maybe from right to left. And what BERT really makes it, what makes BERT really different is that it's trying to understand a sentence from both directions. But also really takes the context of any word into consideration, and also the surroundings. So we will look at that later on in the app, as I mentioned, where we will understand the words that we use, and also the words that we use together with those words next to each other. And we'll look at that, so I can show you what I mean by that. Yeah, generally speaking, BERT is very powerful. The more data you give it, the better it performs. So what data did we actually use? We use the tried and tested Yelp review set from Kaggle, has multiple million reviews, hundreds of thousands of businesses across 11 cities, and we focused heavily on the retail side of things. So we only wanted to look at shopping reviews and focused on these. In terms of feature engineering, we split all those reviews into two main buckets. So we have the positive reviews, which are 4 to 5 star reviews, and everything below that will be a negative review. So what does that data actually look like? Well, we have some graphs for you. For example, we have some word clouds. People who leave a positive review will tend to use words like on the left top word cloud that you can see here, and people who tend to be a bit more critical, they will use very different words. For example, like worst, horrible customer service on the left bottom. And if we try to visualize all of those words that we can see on the left, you can see what it looks like on the right-hand side. Okay, so that actually brings me to our model already. So let's leave the presentation mode and go into our model. Yeah. I hope you can still see my screen. This is where we have a model, and our model, our web app, consists basically of two parts. The first part, and I'm click on this because this might take a while to load. This first bit will give us 5 random reviews of this massive data set, so you can see what those reviews look like, and you will also see the BERT analysis, so we can see what sentiment those reviews are, and we can see what rating we predict those reviews would yield. This might be a bit small in the screen, so let me just zoom a little bit in on that negative review. Yeah, for example, this review, somebody left, probably said something that was more on the negative side of things, which is why we predict it was a negative review. And now, what I've been promising you a couple of times, let's do some live demos. So I'm going to just type in here a random review, like, I don't know. Let's just say I ordered something and I don't know, let's say it was slow shipping and, you know, customer service was friendly. Let's say products are amazing, something like that. Let's try not to do typos. I could have actually used Grammarly. That would be another example of NLP. But let's just do predict here. And let's see what it gives us. So always takes a while. There we go. It is a positive review, and it's okay, cool, interesting. We get 4-star review for this. So let's maybe throw in some more words, and that's what I mentioned earlier with the whole context and the surroundings of every word that BERT is looking at. So let's just say, I don't know, let's just say extremely friendly. There we go, something like that. BERT predict. Let's just see what we get this time. Yeah. Oh, there we go, 5 stars. See, so we just had a 4-star review, and if I throw in another adverb, which then just says, you know, customer service is not just friendly, but extremely friendly, we even get a 5-star review, which actually brings me to the end of our presentation, and that's the time when I would like to invite the rest of the team, my lovely team colleagues, into the presentation, and I would like to thank you for your press this. Hi guys.
Hey.
Hello.
Amazing performance. Congratulations.
Thank you. Thank you.
The question, don't hesitate to ask the question right now. We're going to wait a few seconds if you want to ask a question. No, otherwise I can ask a question. What other models did you try?
We had, for example, a look at the Vader model, which was interesting. Vader is being used heavily on social media. So Vader looks at sentiment on shorter reviews, which is also why we decided against it, because you might have just seen the reviews. They are on average 200 words, roughly 200 words. So Yelp reviews tend to be longer, and Vader did not perform that well on that front. It's great for like a tweet, for example. Vader uses they basically have like a dictionary. It's quite interesting. They have a dictionary, and in that dictionary, once you enter data into that model, it gives you basically the results for all those words, and that also includes emojis, emoticons, for example, as well. If you use, for example, exclamation marks at the end of a sentence, that will change the review. If you start on something positive but end on something negative, it will be more a negative sentiment. Again, great model, but as I said, It's great for long form reviews.
Okay, let's just take a last question, which is from Julio. The question is, how do you know the accuracy of the model?
So we test the model on like a test sample. So we have like 4 million reviews, and we reserve a set of that for testing. So we with an NLP model, with a BERT model, you train it on your data set, and you reserve a part for testing, and we use the accuracy. We look at other metrics to make sure basically it's robust.
Okay, well, fantastic. Well, thank you very much for the presentation. Thank you so much. We're now going to switch to our second group. So our second group had a more financial goal. Their mission was simple. Can we use decision science to beat the bookies? Chris, please join me on stage to make a switch.
Hello. Thanks, Ben. Let me go ahead and share my screen with everybody. Okay. I assume if you can't see that, Ben will just jump on and let me know. So hello, everybody out there. As Ben mentioned, we are Beat the Bookies, and our goal is to accurately predict home victories in the English Premier League and maximize our users' profit using the Kelly criterion. For those of you who aren't familiar with the Kelly criterion, which I wasn't up until about 2 weeks ago, it's basically a formula that uses the predicted odds of an occurrence and compares it with the odds being given by a bookmaker to return an optimal bet based on a maximum set bet amount of the gambler for that given game. Now, don't worry if that doesn't make much sense right now. We'll see it a little bit later in action when I show you the app. First, onto the nitty-gritty for a little bit. For our data set, we sourced the last 12 seasons of EPL matches from footballdata.com, getting the in-game stats, pre-game odds for a win, lose, or draw, and the overall match results. We combine that with the historical FIFA positional rankings for each team from the week with a scrape of FIFAindex.com. And this gave us a total data set of around 5,000 matches with a little over 100 in-game stat points for the teams. From there, we moved on to data engineering. We wanted to prepare the data set for our model. The first thing we did was looking for the key stats that were the most influential in determining a home team victory. We found the highest correlation stood with the differences between the home and away teams' shot on target percentage, their average goals per week, and overall win percentages on the season entering that match. We then added in some custom metrics showing a possible home field advantage score by looking at the difference in how many goals on average the home team would give up in their home stadium versus how many the away team would score when they were typically on the road. As well as home teams' offensive rankings versus away teams' defensive rankings and vice versa. When it came to selecting our model, we tried just about anything we could get our hands on. Neural networks, support vector machines, random forest, and K-neighbor classifiers, but we found our best results with a Gaussian naive Bayes model. We focused in on the model's precision score to keep our game selection as conservative as possible. And looked at setting custom prediction thresholds for the optimal precision profit trade-off. We did find that staying at the standard 50% threshold resulted in the highest total profits. Over the 1,200 match test set that we had, we held a win selection precision score of 68%. Overall accuracy for the model was 63%, and it earned us a little over 300 pounds of profit with a conservative max single game bet of 10 pounds. When we compared it to just a blanketed static betting technique of just putting $10 down on every home team, that resulted in an overall loss of almost 700 pounds for the test set. So with just a few days left until we can actually start to cash in on this, let me show you how it works. I'll just quickly start off by showing the Kelly criterion at work. Here we have the actual game stats, rankings, odds, and results for all the games from the past EPL season. Just pick a week that we can look at. And while we place our max bet amount, feeling pretty good about career week. We think we can do up to £100 per match. And it looks like we did have some overall profit for this week. Here's a great example of the Kelly criterion at work. So our model did predict with 53% accuracy or 53% chance of the home team coming out victorious. So not super high. And with our max game bet of 100, the Kelly criterion said to stay conservative, even with that 3-to-1 odd that we see for the home team, suggesting just a bet of around £8. So as you can see, the game did end in a draw. So we didn't lose our shirts over it, just a slight loss, but we did want to have some skin in the game, trying to capitalize on that 3-to-1. As you can see, we can see pretty much every match from the week and how we predicted and the results. We saw a 33% or a 38% chance for the next match. Again, predicting it accurately as it didn't end with a home victory. We look at the Tottenham-Everton game. Here, almost 60% certainty. So the Kelly criterion did up our bet to close to £20, resulting in a final collection of just about £41. As you can see, for the week as a whole, if we followed the Kelly criterion for this entire week, we would have walked away with almost £230. Now on to some fun stuff. So here we have the full 2020-2021 season that we'll be able to predict. Right now, we do have the official FIFA rankings in there for this week. We've randomized some stats just so it's a little more fun to look at, as you know, every team will start the season with all zeros. Let's go ahead and put a max bet of 200 for this week and see if we can find some games to bet on. So this first match here, it looks like Man City in our simulated season has been off to a really hot start. And the model is saying with almost 97% certainty that they will walk away with a victory, suggesting a bet of almost the max up to £188. Let's just see if we can find one more. Here we see not such a great start for West Ham. So we're going to skip that game. And it looks like Crystal Palace, even though it looks like Arsenal's rankings are a bit better, they do have a slight chance of winning. So we are going to put just a small bet on there, almost £10. Again, like we saw before, we don't want to lose everything, but with over 2-to-1 odds, might as well take the chance. Thank you all. That is the presentation. I'd like to now welcome Nico and George, the rest of my team, to the stage to answer any questions you may have. And let's see, we have a question here from Anna. We used William Hill and their official odds for the model. Anything else? Thank you to Julian. And for Blair, if we had more time, I think really where the money is predicting underdog victories. So we would need some more feature engineering. It is a little bit of a skewed data set. We did attempt to do it with some balancing, but we couldn't get all the way there. But with a little more time, I think we could, and that's really the goal of the app down the road.
Okay, maybe we can take one last question. For example, like can ask you, is the model usable for other sports or league? Because you focused on the Premier League so far.
Yeah, that's a great question. We think it's pretty usable for any professional football league, but we would like to retrain using data from those leagues rather than just the English Premier League. As for other sports, it likely wouldn't work. It would require quite a lot of metrics being reworked, but the basic framework could be used to start building a model for a different sport, like basketball, for instance. So, yeah.
Okay, fantastic. Well, thank you so much, guys. Thank you for the presentation. It was great. Fantastic. Okay, let's move on to our third group. So next up, we have bulber. This one is for the plants lover. If you're wondering which plant is the right one for you, Clement and Felix will tell you right now.
Hello, everyone. So we are bulber with Felix, also with Gael and Mashesh. We're in our team, and we're going to present you the app. But first, a little bit more about pretty much what we've used to create it, why we created it, and then show you a bit how it works. So first, the team. So there was 4 of us, and we decided to go with the neural network powered app to do image analysis and recognition. So yeah, first thing we did was actually coming up with that idea. So it came from realizing that even though there was more and more ways to buy plants around London, it was actually not that easy to always find the right one, and we all had quite tough experiences with some of our plants. So the idea was to find a way to quite quickly figure out if a plant would actually survive in our flat. So what we've done is first looking for different sources where we could gather the data. We use 2 APIs to get the data for how to take care of specific species. And then we started looking further for actually a pretty wide data set to actually have images to then match a picture with a species. So that part was to create a website and pretty much build a code that would pretend to be a user to navigate the website, find the right species, and then extract the images we needed. So once we had these 3, we could just match the data and start with recognizing a species. So first we started with a very dummy sort of baseline model that would be just if we were to pick out of the 25 species we had selected, were to pick randomly what would be the success rate of finding the right species. That's pretty simple. We had a 4% success rate on this one. And so we decided to go a bit further and look into a convolutional neural network to have a better and a bit more advanced baseline. So what we've done is we've used 3 pairs of convolutional and pooling layers. So they're pretty much the first convolutional layer is going to look for specific areas on specific features on an image. And the pooling layer is going to then really focus on these specific layers, and that's going to feed into become the input of the following pair of layers. And then at the end, we're using flattening and dense layers that would then give us our 25 probabilities to tell us how likely it is going to be one of the species or another. So we ended up with a 44% success rate, which was obviously way better than the 4% and already quite strong for 25 species. But we wanted to go a bit further than this, and so we've turned to our data and analyzed the errors that we had, trying to really see which species were returning the most errors and understand why. So one of the main things we've seen is that we had quite unbalanced data sets. So some species had around 4,000 to 5,000 images, while others only had 600. To address that, we've used image data generator, which is from the Keras library, that allows us, so as you can see on the bottom, allows us to go from one image that we have and create new set of images with different brightness or different locations, rotating images. So inflate the size of some of the species and selecting the images that were performing the best. So we could then have our model looking for these specific features. So then we also decided to test transfer learning. So using the BGG16 algorithm model, that was built in Oxford. So it's a very deep convolutional network for large-scale image recognition. So that was right on what we needed. And the way we've used it is also looking convolutional and max spring layers only. It's using way more of those. So there's 16. It's been trained on a lot more images. So it's really good at finding the patterns and recognizing what is in a picture. What we've done is we froze all the weights that were on this model, and then at the end we just typed what we were using on our original baseline model to come back with a 25 probabilities response, one for each of our species, and we trained it again with our images. So from this one, we've actually got a 64% success rate, which is again a big improvement from the first one, and a big improvement from our CNN baseline. So now we're going to show you what the app actually looks like.
Okay, so this is our app. I'll give you a sort of use case for the average plant buyer. We start with this homepage, and we have instructed the user just to input some basic characteristics about the place where the plant will be put. So for the example that we're using, I have in this example, I have an imaginary beautiful terrace with a balcony, a lot of sun exposure. So we'll pick full sun. The plant will have as much sun as you could possibly imagine. And next up, we have to essentially confirm how many times we're willing to water the plant. But for me, in this example, watering plants, taking care of them, it's a big part of my routine, something I love to do. So we're going to pick very often. So the user will just pick the appropriate drop-down selection. And here comes the classification. So the user now is tasked with uploading a plant. We'll take this Carpobrutus edulis, and the model has to think about it with the prediction that we would expect. So out of the 25 species, this is the prediction we get. It's correct. We provide a common name by Hottentot fig, some additional information, but unfortunately, we don't have a match. The conditions that we provided are not good for this specific species. However, luckily for our user, Bulba provides the next best thing. So the model has recognized the sort of bright purple about the flower that we're such a fan of, and has recommended a plant that actually fits the characteristics we provided. So we have a beautiful purple plant that needs to be watered twice a week and needs as much sun as we can give it. So yeah, although we didn't get a match, we do have the next best thing. But in any other case, perhaps the dream case, well, we know the conditions here, so we can input it. We can say medium sun, and we only water it once a month. So now we run the same process. It will give us the same prediction, and luckily, we have a match. So the model can recognize the fact that the conditions that we've provided will match the conditions that the plant needs. And after telling the user that they have a match, then some growing instructions are provided, and a few things to look out for, which can range from pests, I don't know, fertilizer, for example. So yeah, that's the app. We hope you like it. But for now, we're going to invite our colleagues on stage just to answer any questions that you guys have.
Do we have any questions for Bulba?
Okay, so we have first question from Anna. You use 2 APIs for your app. Where is the source of the data?
So actually, it comes from 3 different places, but to ease up the process, we've used the APIs to gather the data, then save them into CSVs for the actual requirements, and then we merge them into our code, and then we can use them back into the app.
Next up from Cam. If you have more time, what other features would you add?
So that's a good question. There's kind of 3 different areas we could look at, but I think the main one would be already to maybe go a bit deeper on how you can describe your place, and then make it a bit more flexible. So let's say you're willing to water the plants twice a week. You're probably going to be willing to do that once a month. So just adjust it a bit or features, and then add more species will be the main next one.
One more question, maybe? No? Okay. Well, thank you very much for the presentation. It was amazing. Congratulations again. Okay, and we are already on our last group. So our last group is more into health tech. They wanted to see if they could identify a skin lesion accurately using image recognition. Please welcome Cameron, who's going to tell us more.
Hi, thanks, Ben. Okay, so as Ben said, our team was looking to create a model that could identify skin lesions. And maybe just as a little bit of background, our project was mirroring trends that are happening in healthcare generally. We're seeing increasing use of AI in medical imaging, basically to improve the time that medical images are scanned. I think, for example, in the last 2 years in the NHS, we've seen an increase of 30% in the number of images requiring interpretation. However, that's only been filled with a 9% increase in the number of radiologists. So AI has a big role to play in improving the times with which scans are interpreted and the efficiency with which patients are triaged. And so for this project, we basically aim to create a miniature version of the platform that many apps, many well-developed apps are currently working on. And so the aims of our project were twofold. Firstly, we wanted to create a model that was capable of identifying different types of skin lesions from images. And then secondly, we wanted to incorporate this into an app that could take not only patient images, but also the accompanying patient data, which I'll go through in a second. So as an agenda, I'll give a brief overview of the data and then the visualization techniques we performed, which then informed our data preparation, our data cleaning. I'll talk you through the model we constructed and how that model performed in evaluation. And then hopefully I'll do a live demonstration of the Streamlit app. So data overview, our data is the HAM 10,000 data set available on Kaggle, and it's basically about 10,000 images of skin lesions and accompanying patient metadata. So the image data set looks like this, many appetizing images of skin lesions, and not to dwell on that for too long. On the metadata, we have information for each patient. So just to draw your attention to DX, that is Y, our target. That's what our model is trying to identify, the type of skin lesion. And then the other 4 bullet points are our X. That's the patient metadata. So how the lesion was discovered, and then patient information such as sex, age, and where that lesion was located, which looks something like this in Python. So then for data viz, firstly, we looked at the distribution of lesions in terms of location, and we found the majority were on the back, lower extremity, or trunk, which was in line with our expectations. In terms of a split by sex, we thought they were largely pretty balanced. There were slightly more male samples than female, but not enough to warrant rebalancing. And then in terms of age, it was a semi-normal distribution around 45 years old, but obviously with expected higher frequencies in the 60-plus age bracket compared to the 30 years and younger. We had a couple of duplicates, about 1,000, and then we had 67 missing values, which in the scheme of 10,000 patients really wasn't that relevant. When we look deeper into the duplicates distributed across our Y, our target, we thought that the distribution was fairly even. So if you see images that have 2 or 3 duplicates, the way that maps the distribution of our Y targets, our skin lesion types, largely maps onto single images, which informed our data cleaning process later on. So we looked at the X, and now we're looking at the Y, our target. So there were 7 different types of skin lesion that we want our model to therefore be able to identify. And you don't have to know what these are. Obviously, about 4 are cancerous, and the other 3 are benign. But they are all forms of ailment. There are no moles or just kind of skin pigmentation. These are all medically recognized ailments that the machine is going to recognize. And so we looked at the distribution of these across our data set, and our data was really unbalanced. You can see that there was many melanocytic nevi samples, when in reality, actually, basal cell carcinoma, the brown column here, is the most common type of skin cancer. And so this serious rebalancing. In addition, vascular lesions and dermatofibra are also underrepresented, which would have affected the model training. So we needed to find a way to create effectively more samples that would more effectively produce a better fit for our model. So then looking at data preparation, so duplicates were deleted because there weren't that many of them, and they were evenly distributed across the target, and our 67 missing values were replaced by means. And then the data set was further cleaned. We undersampled melanocytic nevi. So we took about 1,000 samples at random from the 5,000 that were present in the data set. Then we augmented or doubled the whole data set to improve training on those underrepresented forms of Y targets. And after we'd done that, the distribution across Y looked a lot more even. Yeah, again, those underrepresented samples have a bit more data to train the model on. Finally, we encoded our features using one-hot encoding for categorical features, robust scaling for age, and then we did a custom scaling of the image pixel data. Then for our model construction, so our model basically had 2 elements to it, and I'll start with the left side and then explain the right. So the left side concerned that patient metadata I talked about earlier, those 4 bullet points. So this took the 4 bullet points, patient age, sex, discovery type, and localization, and found associations between that and the type of skin lesion. We had a 3-layer model that then put a multi-layer perceptron output. On the right-hand side is a convolutional neural network we built to take in image data and try and identify the type of skin lesion from that. So I think like Bumble, we used VGG before that, which has fixed layers, and then we added 4 layers customized onto the back of that. We then combined the MLP and CNN output with a final softmax layer to give us our final model. So to evaluate the model, overall in terms of accuracy, the model had 78% top 3 accuracy. To explain top 3 accuracy, the model gives you the 3 most likely skin lesions it thinks you have. And if one of those skin lesions is correct, then we consider that accurate. So now doing a live demonstration with the Streamlit app here. If I enter my age and like, let's leave that as it is. And now if I browse files and I'll put in an image like this, charming, and then we get prediction, we can see that it outputs the top 3 diagnoses of benign keratosis-like lesions. So now finally, Streamlit, and then finally for limitations and future perspectives, our model was maybe limited by hyperparameter tuning. If we had more time, we'd have liked to do a bit more of that. In addition, due to limited computational power, we used slightly reduced quality images when we trained our model. And if we had more time, we'd have liked to have trained the model on full-size images. So from myself, Aaron, Ceci, and John, a massive thank you to Wagon for letting us do this demo day. It's been so fun. And if anyone has any questions, we'd love to take them now.
Any question for skin cancer detection?
How long did it take to build the app? Oof, longer than it should have. Benjamin was very helpful. He was we had a few teething issues, but maybe 5 days. But it should have been a little quicker, to be honest. How big? So the original image set was, what was it, guys? Was it 255?
It was 450 times 600, and we desized them to the fourth of that, so 70 times 75 times 100 we had eventually that we fed our model to.
In terms of other business cases, there are many companies out there that aren't just doing skin lesions. They're applying this kind of learning to X-rays, to CAT scans, looking for brain bleeds, tumors inside the body, and some of the AI applications out there are really sophisticated that they're actually reaching the same diagnosis rates as real life humans. So definitely.
Okay, maybe one last question from Dongjin.
So there's a question, how did we clean pre-process the images and how did we get them ready to analyze? So we got rid of the duplicates, as Cameron mentioned. We also got rid of the fields, the values that didn't have a value in there. So that was the cleaning, basically. We also merged data frames and then used scaling techniques, as you mentioned. So we used robust scaling, which decreases the value of the age between 0 and 1. Because it would be misleading if we had high numbers there in compared to other factors, which would sway the model. So that was the basic pre-processing stuff, basically, and then we could feed that data into the model, and then it could perform well.
Fantastic. Thank you so much, guys. Thank you, everyone, for listening. This was our 4 data science project. I hope you enjoyed it. On behalf of the teaching team, let me say a big congratulations to all of our students for their hard work. We are very proud. I must also say a massive thank you to our teaching team who went above and beyond during the last 9 weeks. They have done a fantastic job, so thank you so much. I'm now going to let Alex, our general manager, to say a few words. Thank you.
Congratulations to all our fresh graduates, as well as of course the teaching teams who've been working with them for the past 9 weeks. I mean, I'm sure that you as impressed as we are by everything that we've seen tonight. It's trust me, it's a lot of work to come from almost zero to building these projects and turn it into something that we can test, that we can present to a public. It is a massive accomplishment. Of course, none of this would be possible without an amazing team. So let me just take time to thank everyone who's been part of this first data science bootcamp in London. So of course, Ben, our data science lead, who's been working very hard to make this a success in the month before that bootcamp, but also throughout these 9 weeks. So many thanks for this. Of course, Lucian as well, who is also part of the core Wagon team, has been, playing a very important role in this adventure. And the same goes for the whole teaching team. So we have Julio, Laurelie, Tom, Paul-Emmanuel, Emma, Mathieu, Blair, Piotr, Davy, and Christophe, who've been with our students throughout these 9 weeks. You've done amazing, and really can't thank you enough for your hard work. I'm already looking forward to the next batch with the same team. Of course, we also have the staff behind these boot camps. They working incredibly hard in the background to make this a success. So we're very thankful to have such a nice team with us. That's very important. And finally, of course, our 14 fresh graduates joining the Wagon community tonight. We know that it's been very challenging. We know that it's been full of ups and downs, but you made it. You made it through the 9 weeks. You did amazing. So thanks for trusting the process. You're now part of a much larger community. It's the start of a long journey, a new career for most of you. So congratulations. Just enjoy that long weekend. That is, of course, well deserved. We're proud of you, and of course you should be very proud of yourself. So For those of you who are also interested in web apps and web applications and web development, we also have our web development demo day coming up at 6 p.m. UK time. So stay tuned. I'm actually going to post the Eventbrite link in the chat. So those of you who are interested, you can also sign up for this demo day. And that's it. Again, very, very well done to all our students, to all our teachers and staff. You can be very, very proud. Have a nice evening, nice weekend. Bye-bye.